In this lesson, we will be learning about the Pythagorean theorem. This is our lesson outline. We will talk a little bit about right triangles. Then we'll talk about the Pythagorean theorem meaning. Then we'll talk about the Pythagorean theorem with some examples with rational answers, pretty much whole number answers. Then we will be looking at and talking about Pythagorean triples. We'll have a mind break. Then we'll go back with some examples that have irrational answers, a couple examples that have real life scenarios using the Pythagorean theorem. And then if we give you measurements, can you tell me if it's a right triangle based off of those measurements? So that is our outline for today. So the Pythagorean theorem is all about right triangles. Okay. All about right triangles. So we need to make sure we can identify the different parts of a right triangle. First off, a right triangle, what makes it a right triangle is that it has a degree measurement inside that has 90 degrees. All right, this is the 90-degree mark right here. It has two legs coming out from the 90-degree angle. One leg here and one leg here. From the 90-degree angle right across is called the hypotenuse. The hypotenuse is the longest side of the right triangle. It will always be the longest side, and that is called the hypotenuse. So a right triangle has an angle that is 90 degrees. The two sides that make up the right angle are called legs. The side opposite, so right across from the right angle, is called the hypotenuse. Now, let's talk about what the Pythagorean theorem means. For any right triangle, the sum of the areas of the two small squares is equal to the area of the larger. So this is the equation, the Pythagorean theorem, a squared plus b squared equals c squared. So let's talk a little bit about that using this picture and what it actually means. So inside, you will see a right triangle. And I'm going to color that in with this color. I'm going to say it's green. Okay. So, for any right triangle, the sum of the areas of the two small squares is equal to the area of the larger square. So here are the two small squares. It's saying if I add this area and add this area together, it will equal this area. So let's look at that. Let's say that this measurement is 4. If this measurement is 4, and if this were a perfect square, that means this side is also 4. So is this one, and so is this one. If I find the area of this square, it would be s times s, so side times side. So 4 times 4 is 16. That's the area of this square. Okay. Well, what if I say that the height of this triangle is 3? If this is 3, this is 3, this is 3, and this is 3, because it's a square. Okay, so 3 times 3 is 9. So let's look back over here again. For any right triangle, this is a right triangle, it has 90 degrees. The sum of the areas of the two small squares, so if I add these up, sum means to add. The answer to an addition problem. If I add 9 plus 16, what does that get me? 16 plus 9 equals 25. That means this area is 25, because if I add these together, it should equal the sum of the larger square. The two small squares, add them up, it equals the sum of the larger square. And if this is 25, well, what number times what number will get me 25? That's the same number. Look here. 4 times 4 is the same number, and it gets me 16. This one is 3 times 3, it gets me 9. What times what makes 25? 5. So if this is 5, that is 5, that is 5, and this is 5. So it's saying for any right triangle, the sum of the areas of the two smaller squares is equal to the area of the larger square. So if I do this, if I say a squared, where does that come from? Oh, 3. 3 squared plus b squared, okay, 4 squared, equals c squared, which was 5 squared. Okay, and if we did not know that, this is what we could do. 3 times 3 is 9, plus 4 times 4 is 16. All right, that makes 25. So that's what it makes, 25. All right, so that gets us this sum right here. So this is a good way to introduce the Pythagorean theorem. All right, as long as you remember that these two, when you add them together to understand the meaning of it, the sum of the two smaller squares can add up to make this one. All right, and if I were to say 25 minus 16, if I were to take 16 away from 25, that will get me 9. Let's go the other way. If I were to take 9 away from 25, I would get 16. All right. So just to clarify one more time, if I were to take everything from here and everything from here, and I add all the orange, and I add the orange up, it will equal exactly what's in that square right there. Okay. And these squares are not perfect squares because I hand drew them, but they should be squares. Okay. So let's keep going. Oh, just to go back again, when we're looking at the Pythagorean theorem and we're looking at the triangles, A, B, and C. C is always the hypotenuse. All right, so that's why in this case it equals 25. And A and B, it doesn't matter if you have B here or A there, or if you switch them. The legs don't matter. The C is the hypotenuse. It always has to be the hypotenuse. So let's look at this example using this formula. Exactly. So I just mentioned how when we're looking at the triangles for the Pythagorean theorem, C is always the longest side. And then this could be A and this could be B, or this could be A and this could be B. It's up to you. You'll get the same answer if you're doing the math correct. Okay, so I'm just going to say this is A, this is B, and I know this one has to be C. So I'm trying to find C here. So I'm going to use the Pythagorean theorem. A squared plus B squared equals C squared. It's always a good idea to write it out yourself. All right, so A I'm saying is 4, and that's just A. I have to square that A. Plus B, which is 3, and square it equals C squared. I don't know what C is, but I'm trying to find that length. If I know this length and I know this length, I need to find that one, and I can use that by using the Pythagorean theorem because this is a right triangle. The Pythagorean theorem only works with right triangles. Okay, so 4 squared is 16 plus 3 squared is 9 equals C squared. Okay, 16 plus 9 is 25 equals C squared. But 25 isn't C, 25 is C squared. So how do I get the value of 1C? Well, do the inverse of a square. Square root. Square root. C equals 5. So right here, C equals 5. Okay, and this is in inches, so it should say 5 inches. Okay, so all we did was assign A or B, plug it into the equation to find C squared for this example. Just follow the formula. Let's look at this one. Okay, so let me write down the formula. A squared plus B squared equals C squared. All right, so I'm going to say this is A, this is B, this one has to be C because it's the longest side. Here's my right angle. Opposite of it, right across from it, is always the hypotenuse. Okay. All right, so A I'm assigning as 8, and then I have to square it because A is squared. 8 squared plus 6 squared equals C squared. 8 squared is 64 plus 6 squared, which is 36, equals C squared. Let me fix that. Ooh, that looks horrible. Okay, equals C squared. 64 plus 36, all right, that's 60, something 90, 100, equals C squared. All right, to get rid of that squared, I square root both sides. Whatever I do to one side, I have to do to the other. C equals 10. All right, so C equals 10 centimeters. Okay. I don't have to write it right here. I could just write it like this, but make sure you put the units in there. And it said centimeters, so make sure you include the centimeters. Next example. Okay, a squared plus b squared equals c squared. Wrote that down. Okay, so I'm going to say this is a, this is b, that's c, because c is always the longest side. Oh, look, they actually gave us the value of c this time. So I'm going to just do my work over here. A squared plus b squared equals c squared. All right, let's plug stuff in. I don't know what a squared is. Plus 12 squared equals 13 squared. Okay, I don't know what a squared is. Plus 144 equals 169. Minus 144 minus 144. That makes 0. A squared equals, all right, 25. Square root. A equals 5. And it didn't give me any units here, so I could just say units. Okay, so the answer is just A equals 5 units. Well, what happens if you labeled it a little differently? What if you labeled this as B and this is A and this is 13? All right, well, this had to be 13. What if you labeled it like that? Well, let's see what would happen. A squared plus b squared equals c squared. You should still get the same answer. Okay, and this was 12. All right, so 12 squared plus b squared equals 13 squared. 144 plus b squared equals 169. Minus 144 minus 144. B squared equals 25. Square root. That cancels, like that one cancels. So b equals 5. You still get the same answer. So it doesn't matter which way you do it, right? Whichever one you label as A or B, as long as they're the legs, it doesn't matter the order, but this matters. C always has to be the hypotenuse. Example 4. Alright, so a squared plus b squared equals c squared. It's the same stuff over and over again. Okay, so actually I'm going to have you practice these two examples. Press pause when I'm done talking and go ahead and try these two on your own and then come back. Go ahead. Alright, so let's go ahead and label these. I'll say this is A, this is B, this one's always C. So 3 squared plus B squared equals 5 squared. Okay. So 9 plus B squared equals 25. Okay. Minus 9, B squared equals 16. Square root. That cancels to make 1b because the square root is the inverse of a square. Okay, so b equals 4. And it's in feet, so 4 feet. So the length from here to here is 4 feet. Let's look at this one. So I'll label this as A, B, and C. Always label them. Oh, remember, C always has to be the longest side, so I can't write that as B. So I need to erase that. And say that this is C and this is B. Okay, so I'll do A squared plus B squared equals C squared. I have to get new paper to fix this. So I don't know what A is, so I'll put A squared plus 9 squared equals 15 squared. A squared plus 81 equals 225. Minus 81. A squared equals 225 minus 81. So 144. Square root. A equals 12. So, and 12 inches. Okay, because A equals 12 inches from here to here. Okay, let's try the next one. Okay, now we're on to Pythagorean triples. So each example that you've seen so far has been, in this lesson, has been a Pythagorean triple. What that means is that each answer that you have seen that we've done has produced a nice whole number. All right, it's not point something, it's not when you're taking the square root of it, it's the square root of a perfect square. That's been very nice so far, and that's what makes a Pythagorean triple. All right, right here, it helps it with it. So if you have a side, these two, the first two numbers always represent the legs, and the last one always represents the hypotenuse. So if you are given these two legs, you know the hypotenuse is always 13. Or if you're given the hypotenuse in one of the legs, it will always be 5. So these are very common side lengths of a right triangle for the Pythagorean theorem, where if you recognize it and you memorize it, you already know what it's going to be without having to do work. So the ones that we've already seen so far was the 3, 4, 5, the 6, 8, and 10, and the 5, 12, and 13. We saw those ones. All right. So these are the ones that produce a nice whole number, a rational number as an answer. All right, it's time for my break. All right, we talked a little bit about a right triangle, the legs and the hypotenuse. We talked about the Pythagorean theorem meaning. All right, so what that means is if I take the sum of the two small squares, it adds up to make the sum of this square. All right, so 4 squared plus 3 squared equals 5 squared. All right, then we did some examples where we had rational answers. And it was just perfect whole numbers, which represented a Pythagorean triple. We did the mind break, and now we're going to go on to looking at examples with the Pythagorean theorem with irrational answers. Then we'll look at real life scenarios. Then if given measurements, can you tell me if it's a right triangle or not using the Pythagorean theorem? Okay, so what is the length of the missing side? Well, in this case, our missing side is C, because C is always the longest side. So I'm going to say A squared plus B squared equals C squared. So I'll label that as A and that is B. It doesn't matter if you put this as B and this is A. It doesn't matter. So let's go ahead and try this. So 8 squared plus 7 squared equals C squared. 8 squared is 64. 7 squared is 49 equals C squared. We're just following that equation. All right, so 64 plus 49. See what that gets us. All right, that gets us 113. C squared equals C squared. So I need to square root this because that's the inverse of a square. Well, this does not produce a perfect whole answer. This is not a perfect square under there. So I'm just going to leave my answer like this. Okay. If you really wanted to find that exact answer, you could plug it into the calculator. The square root of 113 is approximately 10.6. All right, so if you really wanted to know, you can say that. And here I didn't give you the units, so you can just write units. Okay. Well, what if I give you measurements like this instead of a drawing? Well, you can just make a right triangle. It doesn't have to be perfect. Make a right triangle. You know C is the longest side. One has to be 2, and the other one, we don't know what it is. So go ahead and pause it after I'm done talking and try this one out and see what you get, and then come back. All right, so A squared plus B squared equals C squared. So A squared, I'll label this one as A since I labeled this one B. Again, it doesn't matter which way you did it. If you're doing the math correct, you'll get the same answer. So I'm going to have 2 squared plus B squared equals 9 squared. So 4 plus B squared equals 81. Minus 4 minus 4, B squared equals, what is that going to equal? 77. Take the square root of that, square root of that. That's the inverse, so I get back just B. The square root is 77. Okay, and I'll say units. Well, what if by just looking at that you may have no meaning towards that? So if you wanted, you could plug it into the calculator, and the square root of 77 is approximately, remember that's a symbol for approximately, 8.8. So 8.8 units. Okay. All right. Now let's look at this example, a real life situation. So it says, to get from point A to point B. Okay, let's look at the picture. Oh, point A to point B. You must avoid walking through the pond. Why? Are there piranhas? Probably. To avoid the pond with the piranhas, you must walk 34 meters south. Okay, south is down. And 41 meters east. East is this way. Okay, makes sense. If I don't want to walk through the pond, I can go down and then across. Okay, makes sense. To the nearest meter, how many meters would be saved if it were possible to walk through the pond? All right, I have these options. 34 meters, 22 meters, 53 meters, and 75 meters. Okay, so it kind of looks like I'm going to have to do two different situations here. All right, I would have to figure out the distance from A to B. So from A to B, And then I would have to figure out the distance to walk around. So this would be through the pond, and this will be around pond. Well, let's see how long it takes to get if I just wanted to go around the pond. All right, so let's see. Around the pond would be if I go 34 meters this way, because here's the edge of the pond. So if I'm here, I have to walk this way. So it'll be 34 plus walking all the way this way to get to B, 41. Okay, if I add that up, 41 plus 34, I get 75. So 75 meters to go around the pond. Around. Okay, but what if I could go through it? What would that look like? Well, that is where I want to use the Pythagorean theorem. Okay, so if I say this is A, this is B, and this is C, then I can use the Pythagorean theorem. So let's see, A squared plus B squared equals C squared. We're trying to see if going through the pond is a shorter distance than going around it. Okay, so let's see. 34 squared plus 41 squared equals C squared. Whoa, looks like these are going to be big numbers. But we're going to square in the end, so let's see what happens. All right, so 34 squared equals 1,156. 41 squared is 1,681. Okay. When I add those together, I get 2,837 equals C squared. And you can just use a calculator for this or multiply on the side. Square root that, square root that. C is approximately 53. Okay, this is through the pond. So if I'm looking right now, which one is a shorter distance? Walking through the pond or walking around the pond? 53, 75. Through the pond is a shorter distance. It's approximately 53 meters, while through the pond, while around the pond to walk all the way around it is 75 meters. Okay. Whoa, I see 53 and 75 as an answer. Well, let's look at the question again. To the nearest meter, how many meters would be saved if it were possible to walk through the pond? How much shorter is this one compared to that one? Well, it sounds like we have to subtract. So let's see, 75 minus 53 to see how much time is saved. Well, what distance is saved? 22. So our answer is 22 meters. Look, it wasn't even one of those. So it's very important to read the question from beginning to end and make sure you know what the question is asking you to do. Because if I had just did the Pythagorean theorem, I would have said 53 was my answer. Or if I had just thought about walking around it, finding that distance, that was one of the options too. But that's not what it was asking. It was asking how many meters would be saved if it were possible to walk through the pond. All right, so what's the difference in the distance? That's what it's asking. This is a pretty popular Pythagorean theorem real life scenario that you will see. Example 9. A 35-foot ladder is leaning against the side of a building and is positioned such that the base of the ladder, base is the bottom of the ladder, is 25 feet from the base of the building. So the bottom of the ladder is 25 feet from the bottom of the building. How far above the ground is the point where the ladder touches the building? Draw a picture and solve. All right, so we know that we have a ladder that's 35 feet and it's leaning up against a building. Okay. The base of the ladder is 21 feet from the base of the building. Okay. How far above the ground? So how far is this? And this is 35. So let's draw a better picture. All right, so here is the building. All right, here's my ladder. And from here to here is 21 feet. this is 35 feet, and we do not know the length from here, the height from here to here. We don't know that. So let me just draw my picture, my triangle, in a better color so that we can see the triangle that we're looking at. Okay, so if I take that triangle and I put this triangle over here so that I can see it clearly, this is 35 feet, this is 21 feet, and I don't know what that one is. Okay, so it's always good to draw a picture. So I'm going to use the Pythagorean Theorem for this. So let me pick a different color. So I'm going to do a squared plus b squared equals c squared. I'm going to say this is a, this is b, and this is c. C always has to be the hypotenuse, the longest side. So I'm going to say 21 squared plus b squared equals 35 squared. 21 squared, I can do 21 times 21, and when I do, I get 441. Plus b squared equals, I don't know what 35 squared is, so I'm going to say 35 times 35. And when I do that, I get 1,225. Okay. Then I'm going to minus 441 to get b by itself. B squared equals 784 when I subtract b's. I square root both sides because that cancels that. The square root is the inverse of a square, so b equals actually exactly 28. So the height of the building, or I shouldn't say the building, but from the, so it says how far above the ground is the point where the ladder touches. So from the bottom of the building to where the ladder touches is 28. So that's 28 feet. There we go. Drawing a picture always helps. And if you notice, I kind of drew 3 pictures. I started off with what I was comfortable with, the ladder, right? Because that was very clear to me that the ladder was 35 feet and that it was leaning, all right? And then I kind of drew like a messy picture. Then I drew a better picture just for me to see visually. And then I took out the triangle with just the numbers without everything else, just to make it clearer for me. It's up to you how you want to do it. Just make sure you draw a picture if you're not given a picture. All right, example 10. A 17-meter piece of string is stretched from the top of a 15-meter flagpole to the ground. How far is the base of the flagpole from the end of the piece of the string? Draw a picture and solve. So, what I want you to do is draw a little picture of this. Don't solve it yet. Draw a little picture just to see what you're thinking. And then when you're done drawing a brief little picture with the measurements, come back to this so that we can go over it and then we'll solve it. We want to make sure your picture is good first before I have you solve it. Because what if your picture isn't the right picture and you did all that work for nothing? So go ahead and pause it now and draw that picture. Alright, so it says a 17-meter piece of string. So I have a piece of string that's stretched. So it's stretched. And that's 17 meters. Stretched from the top of a 15-meter flagpole to the ground. Okay. Well, the flagpole to the ground. Alright, so let's see. Here's a flag. Alright, and that is 15 meters. And this string is right here and it's going to the ground. Here's the ground. All right, and that's 17. How far is the base, the bottom of the flagpole, to the end of the piece of string? So this is what I'm trying to figure out. So there's my little picture. So I'm just going to redraw my picture. So I'm just looking at numbers. And I'm trying to find that one. Okay. Hopefully you got that picture correct. All right. So I'm going to start plugging it in. A squared plus b squared equals c squared. Okay, so I'm going to say that's a, that's b, this is c. C always has to be the hypotenuse. So 15 squared plus b squared equals 17 squared. 15 squared is 225 plus b squared equals 289 minus 225 minus 225. All right, b squared equals 64. Square root. B equals exactly 8. And this is a meter, so it'll be 8 meters. Okay. All right. If you were stuck on example 10, example 9, or example 8, the pond, the ladder, or this string problem, do them again. All right? Take your time. Do them again. All right, the last thing we're going to talk about today is how to determine if measurements create a right triangle. All right, so if I give you measurements like 2, 4, and 6, okay, you're going to plug them into the Pythagorean theorem in order. So this is a leg, and this is the hypotenuse. So think of A, B, C. Okay, in order. Plug them into the Pythagorean theorem in order and see if it produces a true statement. If yes, the measurements create a right triangle. If not, they don't create a right triangle. Remember, the Pythagorean theorem only works for right triangles. Okay, it has to have a 90-degree angle in there. All right, it cannot work for obtuse angles or really acute angles. All right, it has to be a 90-degree angle in there. Okay, so it says, are these right triangles? Well, let's plug them in. This is A, this is B, and this is C. So I'll say 6 squared plus 11 squared equals 13 squared. Let's see if that's true. So 36 plus 121 needs to equal 169. Okay. Add those together. That's 157. And that's supposed to equal 169. That's not true. That's not a true statement. So these are not the measurements of a right triangle. So not a right triangle. It has to produce a true statement. Let's look at this one. A, B, C. Okay, so a squared plus b squared equals c squared. I should have started with that over here. A squared plus b squared equals c squared. I should always write that down for each problem that I do. So 8 squared plus 15 squared equals 17 squared. Let's see if this is true. 8 squared is 64 plus 15 squared, which is 225, which equals 289. 64 plus 225, that's 289, equals 289. This is true. So this is a right triangle. This is a right triangle. 289 does equal 289. Okay, so you can use the Pythagorean theorem because the Pythagorean theorem only works for right triangles. So if I give you 3 random measurements, you could tell me if they belong to a right triangle by using the Pythagorean theorem. So you go ahead and practice these 2. This is our last slide that we're going to do math on. So go ahead and try those. Go ahead and pause now and then come back. All right, so let's see, a squared plus b squared equals c squared. So 6 squared, because this is a, b, and c. 6 squared plus 7 squared equals 9 squared. 36 plus 49 equals 81. All right. So let's see, when I add those together, that makes 85. That does not equal 81, so not a right triangle. Okay, look at this one. A, B, C. A squared plus b squared equals c squared. All right, 12 squared plus 5 squared equals 13 squared. So 144 plus 25 equals 169. Okay. When I add those together, that's 169. Ooh, yes, that's true. So this is a right triangle. There we go. Hopefully you got those right. All right, and that marks the end of our lesson. All right, hope you have a great day. Bye.